Hello students, welcome to Sunya IAS. So today we are here in yet another session of CSAT PYQ discussion. And so today we are going to discuss about a small topic, but it is such a topic which has applications in various fields, and that topic is nothing but HCF and LCM. I know you might be familiar with this particular two terms because in your childhood you have done nothing but studied these things only. And so we are doing the same thing. The only part is we are going to just study about them from CSAT point of view. Okay, so this is our offline and online course in which we have exhaustively covered HCF and LCM topic for CSAT examination obviously, and now we are going to start our discussion. Before we start, we will talk something about the basics of LCM and HCF. It is very simple. There is nothing great about HCF and LCM. Suppose you have two numbers. Let's say you have 60 and you have 75. Okay. If I ask you, let us find the LCM of these numbers. So what is LCM? LCM is the least common multiple. LCM would be such a number which will lie in the table of 60 also and will lie in the table of 75 also. It would be such a number. Okay. So in order to give an example, if you have 60, what are the multiples of 60? You have 120, then you have 180, then you have 240, 300, and so on, 360. The list goes on. Similarly, if you talk about 75, what are going to be the multiples of 75? Multiples of 75 are going to be 150. Then one more multiple you will have, that is 75 into 3. That would be nothing but 225. Further, you will have one more multiple, that would be 300, 375, and so on. The list will continue even for 75 in this way. But here you can notice that in both these list of multiples of 60 also and 75 also, there is a common value which is nothing but 300. Okay, it doesn't mean that this is the only common value. As we go deeper down, you will find more such common values. Next, there would be 600 and 600 in both these tables. Further, you will find 900 and 900 in both these tables. So the list will go on. You will have until infinity a large number, an infinite number of multiples which will be common to 60 also and 75 also. But we are interested in finding the least common multiple. So here L stands for least, and among all the common multiples they are going to have, 300 is the least value. So the LCM of 60 and 75 is going to be nothing but 300. Now this is the part of explaining you the concept of LCM. We will just find out. I'm just going to tell you the process with which you can actually find the LCM in your examination. So here we have 60 and 75. What we'll do here is that we'll follow a process of prime factorization of both of them together. So first prime number is 2. Here on dividing we get 30. Here this number is not divisible, so we'll write 75 as it is. Then again we divide with 2. Here we'll get 15. Here the number will remain same as 75. Now as you can see, the next prime number is going to be 3. Let us divide both the numbers with 3. Here you will get a 5, and here on dividing with 3 you will get a 25. So the next number is going to be 5. Now we will divide both the numbers by 5. This number will disappear and become equal to 1, while there will be 1 5 left. And finally, if you use one more 5, you will have both the numbers reduced to 1. From 60 and 75 to 1, 1. And now if I multiply all these values, I will get the LCM. So LCM is going to be nothing but the multiplication of 2 into 2 into 3 into 5 into 5. Okay. If you solve this, you will get 4 into 3 into 25. Further, you will get on multiplication the value of 300, which is same as this value which we just calculated. Okay, so that is the process of calculating LCM. Now, as I have done this exercise for you, I expect you to also be a participant in the process of discussion, not just a mere spectator. So you have to do one thing, is that after pausing the video, you have to find the LCM of two numbers, that is 36 and 48. Okay, so this is something which you should try on your part, so that you are accustomed to this calculation which you are going to do in further in this discussion video. All right, so now we'll talk about HCF, or the highest common factor. Let us talk about those numbers again. We had 60 and we had 75. What are the factors of 60 and 75? So 1 is a factor. Here 2 is also a factor, not multiplication. 3 is also a factor of 60. If you divide 60 by 3, you get a value of 20. Similarly, 4 is a factor. 5 is also a factor of 60. And 6 is also a factor of 60, because it divides 60 perfectly. The result you get is 10. Now you cannot divide 60 by 7. You cannot divide 60 by 8, by 9 also. Directly the factor would be 10. So if you divide 60 by 10, you will get the value of 6. Then further you will have 12 as a factor, 15 as a factor, 20 as a factor, and then after 20, the only factor which will be left would be 60. So 60 would be a factor of 60 itself. So these are the whole lists of factors of this particular number, which is 60. If we talk about 75, what are going to be the factors of 75? 1 would be the factor, not 2 but 3. 5 would be the factor. 10, 11, 12, all of these are not going to be the factors of this particular number. And further you can have 15 as a factor, 25 as a factor, and finally you will have 75, this number, as the factor of this particular number itself. Okay, so what I have done here, I have written the factors of 75. What we are interested in finding is the common factors. So what are going to be the common factors here? Common factor, as you can see, 1 is there. Apart from that, 3 is common to both, 5 is common to both, 15 is common to both. Apart from that, there is no common factor between these two numbers. But out of these 3 or 4 common factors which we are having, we need the highest. We need the highest common factor, and you can easily guess which is going to be the highest value. It is going to be 15. Okay, so HCF of both these numbers is going to be 15, right? Now I have explained you the concept of HCF. Now I'll explain you how to calculate the HCF. Okay, so using both these numbers, 60 and 75, what we'll do, we'll just factorize these numbers, but now we'll factorize them separately. So here we have 60, here we have 75. So first goes 2, then 30, then 2, then 15, then 3, 5, one more time, and now we have 1. So this is completely factorized. You can write 60 as nothing but 2 into 2 into 3 into 5. Now let us talk about the other number, that is 75. The first factor is going to be 3. After that you will have 25 here. Next would be 5, and after you will have 1. So the factors of this particular number, that is 75, are going to be nothing but 3 into 5 into 5. So now we have to find the factors which are common. So here 3 and 5 and 3 and 5 are common. So the HCF of both these numbers is going to be 3 into 5, that is 15, which is just equal to the value we calculated earlier. Okay, so this is the concept of HCF. Since we want this discussion to be an engaging discussion, I expect you to find the HCF of these two values, that is 36 and 48. So earlier I asked you to find the LCM. Now I want you to pause the video and just try to calculate the HCF of both these two values. Okay, so that was all about the basics of this HCF LCM topic. Now we'll move on to questions. And now before moving on to questions, I want to give you one slight advice of what kind of questions we are going to expect in CSAT examinations. So obviously, we are not going to get such simple questions that calculate the HCF or LCM of both these numbers. That is not something you will have to find. The thing that you will find are word problems. Okay. So in that word problem, you have to actually identify whether HCF is applicable or LCM is applicable. Okay. So we'll move on in our discussion. So as I told you, this is our offline and online hybrid course. After that, these are the questions, and now we have 5 questions for this particular topic, HCF and LCM. And now we are going to discuss these topics. So let us start. So there are 3 persons who start walking together and their steps measure 40 centimeter, 42 centimeter and 45 centimeter respectively. What is the minimum distance each should walk so that they can cover the same distance in complete steps? So this is something which is, on first look doesn't seem to be a question of HCF or LCM. There's a doubt. How do we apply that? But you have to think. First of all, you have to just understand the process of what is going on. So if we talk about the first guy, let's call them A, B and C. A walks 40 centimeter in one step, B walks 42 centimeter in one step, and C walks 45 centimeter in one step. So if in one step he is walking such distance, so always in whatever number of steps he walk, the distance would be the multiple of 40. So you will get 40, 80, 120, 160 and so on, such centimeters as the distance he is covering in, steps, 1 step, 2 step, 3 step, 4 step and so on. Similarly, if there is 42 centimeter, it will walk in multiples of 42, 42, 84, 126, 168 and so on. So in each step he is going to cover a multiple of 42. Similarly, if we talk about 145, the discussion will be the same, 45, 90, 135, 180 and so on. Now we want to find the distance in which they complete equal amount of distance in proper step, complete step. Okay, so that number would be just some multiple of all these 3 numbers. So actually we have to find the multiple of 40, 42 and 45, but that multiple should also be the minimum distance. That is, we have to find actually the least common multiple. In this part of the question, we are interested in finding the LCM of these 3 values, and that is the question all about. Okay, so is it understood the process that how we apply LCM in this question? So now when we have understood we have to apply LCM, we'll just do the calculation on our part. So what we have to do actually is to just find the LCM of 40, 42 and 45. So we'll begin here. Again, we'll go with 3. Then we'll go with 5. Ultimately, we'll go with a 7 so that all of them become 1. So ultimately, one can say the LCM of these 3 numbers is going to be nothing but 2 into 2 into 2 multiplied by 3 into 3 multiplied by 5 multiplied by 7. And so when we multiply all these digits, we'll get the final number. And that final number actually, will have some value, and what value it has would be 2520. On all multiplication, we will get the value 2520. So here back in the question, we get the value to be 2520, and since the units initially are centimeter, so this answer will also be in centimeter. So we just look at the options. So here we can see it is just converting this into meter and centimeter. So divided by 100, it will become 25 meter and 20 centimeters. And that is option number A, which is going to be the correct answer in this case. This was an application based question of the topic of HCF and LCM. So we'll move on to see further such questions. So in this question, let us read. So it is a very easy question. In terms of calculation also, it is very easy. The only thing you have to do is to just understand the process which is going on. So in a school, every student is assigned a unique identification number. A student is a football player, and if he is a football player, his identification number should be divisible by 4. Whereas if a student is a cricketer, his identification number should be divisible by 6. Okay. If every number from 1 to 100 is assigned to a student, then how many of them play cricket as well as football? So are you able to understand the question? In any question, there is a, in any school, there is a system of assigning some roll number. So here in this school, what is happening, that roll number are assigned in such a way that if a person is a football player, his roll number or identification number will be divisible by 4. And if he is a cricketer, his identification number will be divisible by 6. Now, if we want to find those players who can play cricket also and football also, then in that case, that identification number should be divisible by both 4 also and 6 also. That is, we have to find those numbers which are nothing but LCM of 4 and 6. That is the crux of the question. So on first look, this question may appear very, difficult, very challenging, but when you get the crux, basic understanding, then it's a cakewalk. So we have to just find this simple LCM, nothing painstaking in that. So the LCM is going to be 2 into 2 into 3, and that value is nothing but equal to 12. So those people with roll numbers or identification numbers as 12 or their multiples, not just 12, but all the multiples of 12 would be the players of cricket also and football also. So we are interested in all those multiples. And which are all those multiples? So if we start with 12, then we'll have 24, then we'll have 36, 48, 60, 72, 84, 96, and just we'll stop because the identification numbers are up to 100 only. So up to 100, there are total 1, 2, 3, 4, 5, 6, 7, 8 players which are playing cricket as well as football. So the answer is going to be option number B, that is 8. Okay, so it was a pretty simple question in terms of calculation, in terms of everything. The only effort on your part should be to just understand that in this question you will have to apply LCM. Okay, so these are the kind of applied question UPSC is asking. Okay, so this is the third question. 5 persons are firing bullets at the target at the interval of 6, 7, 8, 9 and 12 seconds respectively. Okay, the number of times they would fire the bullets together in an hour is, okay, so let me tell you the basic idea of a question. There are 5 people. Suppose there is some police training academy we are talking about, and in that IPS training academy, which is incidentally in Hyderabad, 5 people are there who are cadets who are training, and so they are firing their guns at an interval of, one is firing at an interval of 6 seconds, another is 7, 8, 9 and 12. So different candidates are there. Let's call them A, B, C, D and E. So A is firing after every 6 seconds, B after every 7 seconds, 8, 9 and 12 seconds. So here you can see that A will fire at 6, 12, 18, 24, 30, 36 and so on seconds. We talk about B, he will fire at 7, 14, 21, 28 and so on, 8, 16, 24 and so on and so on. They will fire in multiples, but we are interested in finding the time in which they will actually fire all of them together. So that would be nothing but the LCM of all these values. So if you want to find the time interval in which all of them fire together, that would be nothing but the LCM of these 5 digits, that is 6, 7, 8, 9 and 12. Okay, so that is something we are going to do first. So I'll just clear the board and I'll find the LCM. So here we'll go with 2 first. 2 again. And a 2 one more time. And lastly with the 7. So all the digits converted to 1. The LCM is going to be nothing but 2 into 2 into 2, that is 8, multiplied by 3 into 3, that is 9 into 7. So if you find the value, how much it is going to be? If you find the LCM of all these values, you'll actually get the value of 504. And so in 504 seconds, they will all fire simultaneously, all of them. Okay, that is the first part of the question. Now we do not have to find this value, but we are actually interested in finding the time in which, the number of times in which they fire the bullets together in 1 hour. So after every 504 seconds, they are firing bullet together. Now it is being asked how many times in an hour they are doing the same thing. So suppose they fire together in 504 seconds, and the total time we have is of 1 hour. That is nothing but 3600 seconds. So 1 hour has 60 minutes and 60 minutes have further 60 seconds. So 1 hour will have 3600 seconds. And now we have to find the number of times they fire together. Would be nothing but this total value 3600 divided by this value 504, and you will get something around 7.14 and so on, doesn't matter. The only thing which matters here is that in this time of 1 hour, they will actually fire together 7 times. Okay, so that is the basic idea of this particular question. So the correct answer is going to be option number B, that is 7. Okay, so that was just yet another question of HCF and LCM, where you have to figure out that okay, LCM can be applied. Moving on to the next question, question number 4. Now this is a typical question which you might have seen in your classes also, class 8, class 6. These are the type of questions that we see in our basic textbooks of school. So nothing is difficult about it. We have to just find the LCM or HCF as it is clear from the question itself. So the question says the least 4-digit number which when divided by all these 4 numbers will leave a remainder of 2 in each case. So what is happening here? You have a number which is actually a 4-digit number, and when divided by 3 or 4 or 5 or 6, it should leave a remainder of 2 in each case. Okay, so that is about the question. So what is the number in which we are interested? So the number in which we are interested should be, first of all, when divided by these numbers, should leave a remainder of 2. So first thing we have to find is that what is the LCM of these 4 numbers, so that we find the number which is actually divisible by all 4. So first part of the question which we are going to do is LCM of all the 4 numbers. We will find 3, 4, 5 and 6. After finding this LCM, the next thing we have to do is to find that multiple of the LCM which is actually the least 4-digit number. So multiple which is least 4-digit number, and in that number we will have to add 2 so that it will leave a remainder of 2 when divided by all of these numbers. So is it clear? What we are doing is that we are interested in finding a number which when divided by all 3, this, and also it should be a least 4-digit number, should leave a remainder of 2. That is the question, and I have summed up into this 3-step process. What we have to do is to just follow the process to reach up to the answer. So first part says LCM of 3, 4, 5 and 6. Now, as I said, we want this discussion to be an engaging discussion, and that note, I would ask you to actually take the pain of finding the LCM, which is not that difficult a task. And if you find the LCM, luckily you will find that this LCM is coming out to be a very nice value. And when you take the task of actually calculating the LCM, you will get the value of 60. Okay. So such number is 60. Now we have to find as the next step such a multiple of 60 which is the least 4-digit number. So if we talk about this least 4-digit number which is LCM of 60, we have to find a suitable number. So what is the least 4-digit number? The least 4-digit number is actually 1000. When you divide 1000 by 60, what do you get? Suppose it goes 1 time, you will have 40, you get 0 from here. Again it goes 6 times, you will have 360 and you will have a remainder of 40. So until 60, the division is going perfectly. So basically it wants to say that when you divide 1000 by 60, this multiple of 60, that is if you multiply 60 by 16, you will get the value of 960. So 960 is such a multiple of 60 which is 3-digit but the largest. Now we want to find the multiple which is 4-digit and the smallest. We'll just add one more to it, we add 60 to it, and we'll get the value of 1020. And this 1020 is actually the least 4-digit multiple of 60. Okay, is it understood? So what I have done, basically I found the least 4-digit multiple by using some mathematical, just some mathematical games I am playing. So that I am dividing 1000 by 60 to know that exact multiple which is the greatest 3-digit multiple would be 960. And then if you add further 60 to it, you will get 1020. That would be the least 4-digit multiple. So this stage is over. This stage is also over. The desired number is 1020. And now in order to get the final number, what I need to do is that I just need to add 2 to this number so that it leaves the remainder of 2. And that number would be nothing but 1020 plus 2, that is nothing but 102. Okay. So option number B is the correct option. Okay, so it was a good question. It was a basic question. These are the questions which you just see and you get the idea clicked in your mind that, oh yeah, I have seen such a similar thing. I have seen such things in my, class 8 or even before. But here we have to apply LCM, then you can proceed further to the question. And now coming to the last question of the day. This question might seem to you not at all even related to LCM, but here we'll apply some basics of LCM. So even before we start, I want you to go give a good read to this particular question because it has a lot of information that we'll sort out eventually. But please give a brief moment of time just to understand what is going on here. Okay, so I hope you might have paused the video and just read the question once in great detail. So what is happening here? Let me explain you the question. There is a person X who wants to distribute some pens among 6 children, and the 6 children are A, B, C, D, E and F. Okay, so that is the scenario. What is happening here? A gets twice the number of pens received by B. So A is getting 2B, twice the number of pens. A is getting 3 times the number received by C. So A is nothing but 3C. 4 times that of D. So A is nothing but 4D. 5 times that of E. And finally 6 times that of F. So A is nothing but 6F. Okay. You can also rewrite this particular equation in the form of B is nothing but A by 2. C is nothing but A by 3, D is nothing but A by 4, similarly A by 5 and A by 6. Okay, so what I'm doing here is that I'm converting all of these digits, all of these values in the terms of A, so that all are almost similar. Okay, so now what the question further says? The question further says that what is the minimum number of pens X should buy so that the number of pen each children gets is an even number. So now you want to distribute pens among all these 6 children in such a way that it is following this particular pattern, and you must ensure that each children is actually getting even number of pens. So just pay attention to this question. It is a very good question, and it is something, it is that question which UPSC surprises people every year with. And so just understand what is going on. So first of all, we have to understand what is the total number of pens he had to buy. Total pens he would have to buy would be how much? A plus B plus C plus D. Okay, for each of the 6 children you will have to buy some pens. I'm just adding the number up. Now here, using this particular relation, you can say the total pens A would be the same. B you can write as A by 2. C you can write as A by 3. D you can write as A by 4. Further, E you can write as A by 5. And finally, F is A by 6. When you sum them up, you must know that these are fractions. And in order to find the sum, you must know how to add fractions. So this is the basic which you will need to solve this particular question. And here is where LCM is actually applied. Okay, so this is the place we are going to apply LCM. And so these are the basics of adding of fraction and subtraction, addition, subtraction, etc. The operations which we do with fractions. We all have covered in our courses. So I'll just move on fastly so that it doesn't take much time. And so here, what is going to be the LCM of these 5 numbers? We are interested in finding actually the LCM of 2, 3, 4, 5 and 6. And I know that you can calculate that very easily, and that LCM is coming out to be nothing but 60 again. So here we will take a common denominator of 60. And in order to add up all these fractions, we will modify them in such a way that all the denominators here are 60. So here we will have A divided by 1, multiply and divide by 60, you will get 60A by 60. So here we have 60A. Similarly, you just multiply with 30 in the top and bottom, you will have 30A by 60. That is nothing but 30A. Similarly, you will have here 20A. Here you will have 15A. You will have 12A. And finally, you will have from here 10A. So if you add up all these values, you will get a nice good value, and that value would be nothing but 147A upon 60. Okay, that is the total number of pens that he should buy in order to distribute the pens in such a pattern. But one thing you must know, that if you are going to buy a pen from a market, you must know you can always have some integer value of number of pens. Okay, you cannot, you will go to the market, you will say give me 10 pens, 15 pens, 100, 200 and so on. You cannot go to the market and say I need 15.5 pens, or I need 6 2/3 pens. You cannot ask the number of pens to be a fraction. This number here, total number of pens, 147A by 60, this should not also be a fraction. That is the case. So let me just erase it up and write that value here again. So after all this fraction addition using the LCM topic, we'll have the number of pens actually to be total pens to be 147A upon 60. Right? Now we must know that A should be a multiple of 60 so that we get a perfect number here. So A should be either 60 or 120, 180 and so on. We can have different values of A. Now the only condition which should be satisfied is that which is given here, that each student is getting an even number, and this is very crucial to solve this particular question. You must ensure that each student is getting an even number of pen. So let us first try with the value of 60. Suppose here, if A is getting 60 pens, what is going to be the number of pen which are actually got by B? B will get 60 by 2, that is 30 pens. C will get 60 by 3, that is 20 pens. D will get 60 by 4, that is 15 pens. He will get 12 pens and he will get 10 pens. So out of these, all are getting even number except this guy. D is getting actually 15 number of pens. Okay. So obviously the value of A cannot be equal to 60. So now we'll try with some another value. So let us try with this particular value of A as 120. So if we put A as 120 here, what are the values we are going to get? So B will get A by 2, that is 60 pen. C will get 40. D will get 120 by 4, that is 30 pen. It will get how much? 24. And finally it will get 20. So now in this case, everyone is getting an even number of pen. So the minimum number of pen that he should buy should be such that A is getting 120 pens. And so here final answer is not 120. We have to find the total number of pen. The total number of pen would be this. So here we'll just put the value of A to be 120. So we get total number of pen. Let me write it here. Total number of pen would be 147 into 120 upon 60. This will get cancelled. You get 2. And here finally you will find 294 as the number of pens. So option C is going to be the correct option in this particular case. So this was a very good question, and here the concept of LCM is applicable, and more than the just way of finding the LCM, the idea of the concept which I told you earlier, that this multiple thing you cannot get anywhere, you cannot get it in any book whatsoever. Okay, because they are just giving you some tricks to find the LCM. Here not the trick, not the formula, but the concept of LCM is being applicable. So it is a really good question, and therefore I'll just repeat it for you once. So I have written down first all the equations, then I found out the total number of pens. It is coming out to be a fraction. Now number of pens could never be a fraction, so A should be a multiple of 60, that is 60, 120, 180 and so on. So now I put the value of A is 60 and check the number of pens each of them is getting. Now in that case, when A was 60, D was getting only 15 pens, which is an odd number. I want everyone to be getting actually even number of pens. So I tried with the value of 120, and now everyone is getting good value, that is all of them are getting the value of 60, 40, 30, all are even numbers. So that A is nothing but equal to 120. But as a word of caution, our final answer is not 120, but it is this 147 into 120 by 60, and further you will get the final answer as 294. So guys, that was all about HCF and LCM, which is a really important and very short topic which you can cover very fastly. And thank you so much guys for your time and your efforts. So thank you very much.